In this video, I want to do something that's somewhat different from the usual sort of lecture videos. I want to talk about the basic skills you need to have to succeed in physics. And I want to talk a little bit about the approach that you should have to your learning of physics. So let me give you an analogy, right? Imagine you watch you turn on TV and you watch some Bruce Lee movie. He runs around and does his kung fu, fancy combinations, fights 20 evil guys at once with kicks and jumps and spinning around, all that stuff. And you're like, wow, that's amazing. I want to learn how to do that. So you go out into the world to find an instructor, a kung fu instructor, a sifu, and you say, hey, I want to learn to fight like Bruce Lee. Now, chances are you're going to spend a long time at the beginning just punching a bag or punching the air. Sometimes with your left, sometimes with your right, doesn't matter, right? Sometimes you get to kick it too. But your first priority is going to be to work on your basics, right? There's no point you learning to jump and do some sort of fancy combinations if your punches are weak, if your kicks are weak, if your balance is off, right? So those are the basics that you need, and then you can build on it. And if your basics are strong, if your foundation is strong, the more fancy stuff is going to come easy. Or let me give you another example, another analogy. Suppose you and your friends, you get together, you want to found a soccer team, and you want to win in some local competition. So you start talking strategy. Right. We're going to have a striker here. We're going to have a little trick here where we outsmart the opponents. We're going to have 4 people here, 2 people here, and if the opponents do this and that, then we're going to respond with the right flank, the left flank. All that stuff you see, professional teams do on TV. You analyze it to death. Then you get out in the field and you realize that none of you can actually kick a ball in the right direction. So all this strategizing, all that thinking about the complicated, the advanced stuff means nothing if you don't have the foundations. So instead your time is better spent actually trying to kick a ball in the right direction. If you can do that, and you can run with the ball, and you can run fast, and you have stamina, right, that's going to win you more games than thinking about a fancier strategy. Or let's take one last example. Suppose you're trying to learn to paint. You can start, analyzing all sorts of paintings of the great painters in terms of composition and color theory and all that stuff. But at some point, you just have to hold a paintbrush and start doing it. And doing it over and over and over until the actual process of actually putting paint on paper becomes automatic, becomes natural to you, right? And then all the thinking and reading about composition, color theory, then that becomes relevant. And you probably figure out a lot of it yourself just by doing the basics. You can think of any other example. Think of cooking, right? You come up with a similar idea there, or any other sport. You need to have a strong foundation, and physics is no different. Physics, yes, it's a science, it's mathematical, it's rigorous, but it's also a craft. You have to practice it. You as a human being have to practice physics to get a feel for the ins and outs, to develop a certain natural understanding of it. So let's figure out what are the basic skills that you need for physics. So one thing you probably can think of right away is you need algebra, right? Algebra constantly comes up. You have to rearrange equations, you have to solve for unknowns, you've got to eliminate other unknowns, you've got multiple equations, all that stuff, right? You shouldn't have to think about it. Yes, it might take time to perform some long-winded algebraic manipulation. But you should know at the beginning that, okay, now I've got to do a bunch of algebra. You should have to think about, am I able to do this? Am I able to isolate this variable? Right? You should just look at it and say, yes, I can do this. Okay, let's sit down and just do it. You need arithmetic. What's the difference between algebra and arithmetic? Arithmetic is actually numbers, right? These are your, do you know your times tables? Sounds basic. Okay, what's 12 times 7? Okay, too late, right? So you need to just know those so you can see the patterns, so you don't have to worry about it. Math is about patterns. And just knowing the basic patterns of basic numbers is just something you need to have up your sleeves. You don't have to do, some 6-digit number times some other 6-digit number, then take the square root in your head. Nobody's asking you to do that, but you need to have the basics down. You can maybe estimate answers without a calculator, right? The calculator shouldn't be this black box that numbers go in and numbers come out. It should be something that is a shortcut, where I could do this without a calculator. It just would take me longer. You need to know about vectors, right? Especially in a course like this. You're going to need it. Lots of things in physics are vectors. You've met a lot of them already in 161. Going to meet more of them in 162. Right? So in this case, you need to know stuff like how to add vectors, how to go from angle and magnitude to components, right? Dot products, cross products maybe, right? Those are things you just need to be able to do mechanically. You need to not think about it. You need to not worry about whether or not you're going to be able to do this. But yes, it can take time. Yes, it can be messy on paper. After 10 lines of manipulating stuff, finally you get to the answer. And we all make mistakes. That's not the point. The point is that you can do it in principle. And you're not doubting whether or not you're actually going to be able to, say, solve a problem because your lack of an understanding of how vectors work. Calculus. Right? What is calculus? Well, differentiation and integration. Because that's just the beginning. Later on, you'd meet differential equations. Other more complicated forms of integration. But right now, right, just the basics. Differentiation and integration. And I'm not asking you here to fully understand every last little detail of what does it mean, what are all the applications, what are the theorems. No. This is about the mechanics. You need to know the mechanics of it so you can do it. The understanding comes with practice, with doing it, with seeing examples, with thinking about examples. You'll figure out the more sort of nuanced understanding of, say, calculus. But right now, if I give you a function, ask you to differentiate it, you should be able to do it. You should sit down and do it, not think about it. Right? It should be mechanical. Trigonometry. Right, very basic. Sine, cosine, tans. Right? Can you find different sides of a triangle? Can you find the angles? And what does a sine or cosine function look like? And can you visualize what that function, like how the shape of that function as a sort of wave relates to the sides on a triangle? Geometry. Right? Can you, find if this angle is one thing, if another angle is another thing? What's that angle over here? What if they're all, in the same circle? Whatever it is. And again, we're not asking you for the most complicated sort of Euclidean geometry theorems. This is applying basic geometry to finding, okay, two sides are parallel. There's one line cutting them. Those angles are the same. And I think a lot of you can do most of this, but you need to be able to do it without thinking about it. Right? These are your basic skills. These are your punches and your kicks. You need to know how to execute a correct punch or a correct kick. without having to think about how to punch or how to kick. Only then can you move on to advanced stuff. But if you do know how to punch, and you do know how to kick, and you do know how to stand so that you keep your balance, then anything that's more advanced is going to come very naturally to you. And that's the same idea here in physics. So these are all math skills so far. Let's look at some things you might consider sort of physics foundations. So let's think back to Phys 161. What did we have there? Well, you started with kinematics, right? Well, is it a basic skill you should have? All those velocities and accelerations. Well, what was kinematics? Essentially, it was the notion of, okay, there's a thing called position. We define the velocity as the rate of change of position. We define acceleration as the rate of change of velocity, and maybe in more than one dimension. But that's it. The rest is knowing how to do calculus and knowing how to do algebra. Right? Maybe I should also put graphs up here. Right? Interpreting, drawing graphs, and understanding graphs and functions. So if I ask you to draw some simple function, can you do it? So maybe those would come in here too. But really this is enough, right? So your kinematics, this whole topic of kinematics is nothing but an application of basic skills and two definitions. Right, that's it. What about forces? You know, you spend weeks dealing with forces. Tension and friction and stuff on a ramp and gravity and all. But in the end, all you ever did was you applied Newton's laws. Right? Newton's laws and vectors and geometry and algebra and all that stuff. And if you didn't do as well as you wanted to on the topic of forces in your midterm or your homework or whatever, well, was it because you didn't understand Newton's laws, or was it because you couldn't apply this stuff? I think for the vast majority of you, it was not applying this stuff correctly. Yes, you have to visualize the situation, but if I say, someone pushes the box from the right and it is on an inclined plane, you can see that in your head. So turning it into the correct mathematics, if you can't do that, that's because you're missing those skills, or then they're not natural to you. You have to think about those. The more things you have to think about at the same time, the harder it is to solve something, right? So this one doesn't really anything here except definitions. This one, Newton's laws, okay, they are a non-trivial set of statements, right, about how the physical world works. That combined with, the force of friction is this. And Newton's law of gravity says this. Right. So, but most of the problem solving that went into this, well, that were these topics here, right? Those are the things you have to be good at. Then dealing with forces is easy. What about energy conservation? It's another basic sort of thing that comes up in physics a lot. We're going to see it again in 162. Well, energy conservation itself is actually fairly straightforward, right? You look at this situation, you ask what's the energy, what are the relevant types of energy, maybe it's kinetic, and one type of potential or another type of potential. Yes, you need to understand those concepts, but actually solving problems is, again, it's algebra, maybe some calculus, maybe some geometry, maybe some graphs, functions, whatever. It's, what is it? It's essentially a bunch of basic skills plus one physics principle, let's call it that, right? Energy is conserved. And here are some expressions for potential energy, for a spring, or gravitational potential energy. But all the problem solving you did, right? All your homework problems is mostly what to do with this. This is the application of those basic skills. Well, you just applied it to a situation where you had this energy conservation thing. If you got stuck in various problems, it was because you weren't applying this. Right? So suppose, you watch this Bruce Lee movie and you decide you want to learn it yourself. So you keep practicing that, double spinning, jumping roundhouse kick. And you think you're getting good at it. But the first time you actually try to apply it to anything, it just doesn't work. You miss, or your kick is really weak. You're really just dancing, and you're fooling yourself, right? If you want to get good at any of the advanced stuff, you need to stop thinking about those. You need to have those down so they come naturally to you. Of course, it happens with practice, right? You get good at those through practice. And it could be practice that involves some more advanced actual physics concepts. But when you do encounter, say, some problem involving, say electrostatic forces, something we're going to do in this course, FIS 162. Right? You encounter those. Well, if you feel like you're getting stuck, not because of your understanding of how electrostatic forces work, but because of this, say, or because of this, or geometry, right? Then you need to pause and really dissect why it is that you're getting stuck. What is it that you're not understanding about the basics? Or what is it that you have to think about hard in order to apply it? Right? So you've got to be self-reflective. There's no, easy magical way to getting good at physics. It requires practice. The same way to get good at punching or kicking, you have to punch and you have to kick. And to kick a ball in a straight line when you want to play soccer is you have to practice kicking balls. And you can do that while playing a game of soccer. But you're only going to get better if you actually sometimes pause and ask yourself, okay, why do I keep kicking the ball always to the left instead of in a straight line? Right? So you really have to master these basic skills, and then the rest of physics will come a lot easier to you. Right? New topics will make sense, because you can dissect them in terms of stuff that you know extremely well and maybe one or two new ideas. And that is going to be particularly important in Physics 162, where, from my experience, from what I've seen, there are a lot of concepts that seem very confusing. But the connection between them is going to become very clear if you have a good grasp of the basics. I hope this makes sense to you. Right? And I hope you can think about this as you do problems, right? As you try to make sense of the new topics you're encountering. Are they hard because the physical ideas are inherently difficult? Probably not. Are they hard because you're struggling to apply those? Well, that means you have to work on your basics. You have to be reflective about what your skills are and what you have to work on. Alright, good luck.